Let's see how to determine the domain of a log function. So remember we talked about earlier, log function and exponential function, they are inverse functions, right? So remember, what is the domain and range for exponential function? Exponential function's domain is all real numbers, right? And the range is a set of positive numbers. So the log function is the inverse of exponential. That's why domain and the range should be, also flipped, right? So the domain of the log function should be a set of positive number, and the range should be all real numbers. Okay, so this is the log function's range. Okay, for the log function, the domain should be a set of positive number, and then the range should be all real numbers. Okay, log function domain is a set of positive number, range is all real number, right? All right, now let's look at an example how to find the domain of a log function. F of x equals log 2 as the base of x plus 3. Okay, so we need to make sure, okay, the restriction for log function is x plus 3 must be greater than 0, right? Set of positive number. So we can easily solve this inequality by subtract 3 on both sides of inequality. So we solve x greater than -3. Or if you want to write an interval notation, is -3 to positive infinity. Both open, okay, because no equal sign here. All right, let's look at a B. G of x equals log 5 as the base of 1 plus x over 1 minus x. So the restriction will be 1 plus x over 1 minus x need to be greater than 0. All right. So now ratio is greater than 0. Okay, only two cases, right? First case, 1 plus x, 1 minus x, they're both positive number. Okay, and then the ratio of two positive numbers, they're still positive numbers. Okay, or another condition, 1 plus x, 1 minus x, they're both negative numbers. So two negative number do divide, okay, division, and then the ratio is still positive number. Okay, only these two cases. If one positive, one negative, and then the ratio is negative, right? One negative, one positive, the ratio also negative. So only either both positive, both numerator denominator positive, or both numerator denominator negative, and then the ratio, it will be positive. So now we have to solve those individually. Okay, inequality, we solve this one, x greater than -1. We solve this inequality, is add x on both sides, so x less than 1, right? We're solving this inequality, and then is x less than 91, and then we solve this inequality, is x greater than 1. So remember, these two are a pair, these two are a pair. Okay, so combine the first one, we can derive is 91 less than x less than positive 1, right? We got a combined inequality. Combine these two, and then we cannot find such a number less than -1 and greater than positive 1 at the same time. So this one, no solution. All right, so the domain for g of x is x must be a number between -1 and a positive 1. If you want to write as an interval notation, you can write as this. All right, the last one, h of x equals log 1/2 of absolute value of x. So we have to make sure absolute value of x must be greater than 0. So if x is a positive number, and then absolute value of positive number is still positive, right? If x is a negative number, and an absolute value of x is also a positive number. So the only thing we need to exclude is x cannot equal to 0, right? Because 0 absolute value is still equal to 0. 0 does not greater than 0. So that's why all we need to exclude x is 0. X can be any positive number or any negative number, but x cannot equal to 0. Okay, that's the domain for h of x. If you want to write as the interval notation, exclude the 0, it just from negative infinity to 0 and from 0 to positive infinity. So only number not included is 0, right? All right, that's the solution.